In today's video, we're going to look at how to convert from moles of one substance to moles of a different substance. First, let's look at things that we already know. We know about recipes, we know about how to make certain foods, and so we're going to look at a muffin mix. So if we were looking at the muffin mix and we bought one at the store, it would tell us we need 1 bag of the mix, plus we need 2 eggs and a cup of milk, and that will make a total of 12 muffins. So the way that we've written it out here is basically in the same way we would write a chemical equation. The numbers in front of the different substances are what we call coefficients. Those coefficients tell us the ratio of each substance to each other in order to come out with the desired outcome. So if we decided we wanted to look at the ratio between two specific things in the equation, if we want to look at bags of muffin mix to the numbers of muffins made, we look at the coefficients. Those numbers tell us what we need in order to get the desired product. So if we look at this ratio, we take those numbers and we put them next to each other, we have a 1 to 12 ratio of muffin mix to muffins. In this case, we've compared the ratio between one of the reactants and one of the products. We are also allowed to compare the ratio of two different reactants. For example, if we looked at the ratio between muffin mix and numbers of eggs. Again, we look at the coefficients and it tells us for every 1 bag of muffin mix, I need 2 eggs. So again, we write that ratio as 1 to 2. So now let's apply this to an actual chemical equation. So if we have this equation where we're mixing nitrogen and hydrogen to form ammonia, we again can look at the ratios that are involved with producing this outcome. If the question we see asks us to find what the ratio is between hydrogen and ammonia, we again look at those coefficients and we see that we have a 3 to 2 ratio. We are also allowed to look at the opposite direction, and so far we've done reactant to a product. You can also make the ratio go from product to reactant. So if we want NH3 to N2, then we'd put the 2 first, a 2 to 1 ratio instead of a 1 to 2. So the order of the things in your ratio is significant. So keep that in mind as we move forward. So again, let's stick with certain things, dealing with things we know, sugar and flour, again, if we were cooking. So when we put the ratio, it says we're going to make them into a fraction, so we're going to put one on top of the other. Whichever unit you are looking for is the unit you're going to put on top. So if we were looking for flour, we would put 3 cups of flour to every 5 cups of sugar. So we have a 3 to 5 ratio. If we were looking for the sugar, we would have written it the opposite. Now, just a quick little reminder when you're doing your math in these things, remember that if you have a number multiplied by a fraction, everything on top gets multiplied together and you divide by whatever's on bottom. We want to be sure that you don't make simple math errors and can get the right answer after you've set it up correctly. The other thing to remind you is that if we have a unit on top of a line and a unit on the bottom of the line, those units will cancel out. In this case, we had kilometers on top and kilometers on bottom, so the unit canceled, but it left us with the numbers. So if this were the problem we were looking at, we would have 5 times 1 divided by 1.61. Going back to our muffin mix analogy, if our question asks, how many eggs do you need to make 60 muffins? So we know that we're going to connect those two pieces, the eggs and the muffin. So first thing we do is we find our ratio. And our ratio of eggs to muffins would be 2 to 12, because we look at the coefficients and those are the numbers that we get. So when we put it into our ratio, it said how many eggs do you need? So eggs is what we were looking for, so we put that on top and we put muffins on the bottom. So our ratio is 2 eggs makes 12 muffins, 2 eggs to 12 muffins. So if we wanted to find out how many eggs we need to get 60 muffins, we start with our given there. And if you notice, we now have muffins on top and muffins on bottom, so those units are going to cancel out. Now we're left with our numbers. So we're going to do 60 times 2 divided by 12, and that would tell us how many eggs we need. In this case, we would need 10 eggs in order to make 60 muffins. Now the same thing works when we're doing it with chemical equations. So in this case, we've got a sample problem. Our sample problem says if 4.3 moles of oxygen are consumed in this combustion reaction, how much carbon dioxide is produced? So the first thing we need to do is to be sure that we balance the equation. We can't figure out our ratios if we don't have the coefficients. In this case, we would balance it with these numbers. Once it has been balanced, then we know our numbers so we can make our ratio. So our step 2 is we identify our given. We are given 4.3 moles of oxygen. So oxygen is the one that we are given information about. The next thing we need to do is to figure out what is our unknown. What are we looking for? And our question asked how much carbon dioxide is produced. So this is going to be our unknown. The next thing we do is we need to identify the required ratio. So the things that we're comparing here were oxygen and carbon dioxide. So we're going to ratio between oxygen and carbon dioxide. So we take those coefficients that are next to them, and we find that we have a 5:3 ratio. Our next step is we calculate the moles of the unknown. And the way we do that is we take the given from the problem and we multiply by the ratio that we've just found out. In this case, the 5:3 ratio, and that will tell us our unknown. So our given was 4.3 moles of oxygen. Next, we're going to have our ratio. Remember that what we're looking for is going to go on top, and what we're trying to cancel out is going to go on bottom. So if we look at our ratio, we know that the 3 has to go with carbon dioxide, and the 5 has to go with the oxygen. 3 moles of carbon dioxide is produced from 5 moles of oxygen. At this point, our moles will cancel, and we're left with our numbers. We have 4.3 times 3 divided by 5, which gives us 2.6 moles of carbon dioxide. If we started with 4.3 moles of oxygen, we end up with 2.6 moles of carbon dioxide. And that is all we have to do in order to switch from moles of one substance to another. In our next video, we're going to look at how to convert between grams of one substance to grams of another. We'll be using this information that we did here in converting from moles to moles in order to convert from grams to grams. So it's important that you understand this video before going on to the next one. So good luck with this, and I will see you next time.